So we originally had to have thought to have one AI panel. We split that. So you've heard the first part, which was more generally about AI, AI policy, and all that. So this is more about talking to practitioners of AI. And we have, I think, a very good mix here on the panel, not just gender-wise. We have an incumbent, a big industrial company. We'll get that perspective. We have kind of a startup, even though you're pretty old startup.
Pretty old, yeah.
Yeah, okay. And since this is not a panel, we have equal representation here. I'm going to start with the male member. Chris Arago, tell me what you do. I mean, this is not your typical AI. This is not kind of speech recognition and all that. So give me an idea. Give us an idea what your company does, what you sell.
I think a lot of people misinterpret AI because they don't want to say what AI is really about. So they talk about prediction and pattern matching and all these things. What AI is really about is automate stuff. And we have built a platform to automate anything. Like, that was the original dream of artificial intelligence when Marvin Minsky put it out there, said we need to find a machine that can solve problems. And that's what automation is. And it's the kind of machine we've produced.
But isn't it a bit self? So when you started your company, AI was something different. It was kind of symbolic reasoning. It was automation. Now it's much more deep learning.
Well, I mean, there's many things that go wrong with AI. Like I typically, when I do talks about AI, I have these 3 things you have to know that AI is not. And one of the last one is AI is not just deep learning. Right? There are many algorithms to AI, and because the way that research is financed, we have for the last 60 years, probably, financed AI in a way where we've always only financed one set of algorithms. So we started out with expert systems. They didn't work. Then came the first machine learning algorithms, like support vectors and so on. They didn't work. Then came knowledge management systems, and they didn't work. And now we are back to learning, which is, and have focused on deep learning. Those algorithms also, each of those algorithms is valid, but all of these algorithms have limitations. Like, for example, in learning, if you want to do deep learning, you need data. And unfortunately, there's not enough data to describe now. So eventually, you're going to end up describing something that is happening over time to a machine. The machine thinks it's the average of that time, right? And you get bad decisions. So the most dangerous thing that AI can do to itself is always proclaim that there's one algorithm that will do it all. And the secret that all the people who put together like more generalistic AI solutions is we combine algorithms, right? We use, for example, learning to deal with ambiguity and incorrectness and unexpected events. And we use reasoning to deal with unspecified knowledge, like to get the optionality into systems. And you use semantics to kind of remember what people have already told you. So this whole idea of that there's one algorithm that will do it all is very sad. And you can already see this limit of not enough data to describe the now is approaching extremely fast. I once had this prediction it would hit us in 2022 or so, and I think it's probably going to happen next year at the speed that we've done it.
But boil it down for me, kind of. I'm not a techie. I'm kind of more a political scientist. When I work as a customer with Arago, how does that work? Kind of, what do you do for me? What do I want as a customer typically?
You want something that is either extremely intense in resources today, where you keep people busy that have better things to do. Like our first commercial usage ever was IT administration, because for the 2 screw-ups you have in your IT environment, you keep really well-educated people sitting there and you bore them half to death the rest of the year. Plus it's very expensive. Then we started outsourcing this to India. Then we didn't know how our company's IT worked anymore. So that was one of the parts. And now we're in many different areas. Also, the question of what can you do if you can set an unlimited number of people to a problem? Let's take rare diseases, for example. I can examine you and I can treat you in terms of what's in your genetic profile. Unfortunately, how much time would I get a human geneticist? How much time are you willing to pay for to actually get a good prescriptive treatment so you don't have the whatever rare diseases that you could be getting in your lifetime? And normally you're not willing to pay so much because these people are very expensive, right? So what happens is we'll give a geneticist 2 hours to look at your sample, and that's it. If they haven't found anything outstanding that will kill you immediately, then we're not going to do anything for you. But what if we take the experience of the geneticists, put them into the machine, and let the machine work on this for a couple of hours. This is like having a geneticist sit there for 20 hours just looking at your stuff. Like, that's what happens in there. You can multiply the work of people. You can multiply the experience of people. And you can use this in all types of, I mean, we feed chicken with an AI. We maintain trains and planes. We do logistics. We play games with AIs. It's great fun.
Great, thanks, Chris. Grazia, now Airbus, we know, makes planes and satellites and all these big choppers and big things, but AI seems to be increasingly important for you. Kind of tell me how Airbus uses AI, how you use data, how you kind of make yourself smarter.
AI is absolutely big on our minds, and there's almost as many applications as products. Our product portfolio is extremely wide, and there's very many examples of already successful application of AI. Starting, for instance, when we acknowledged on our production lines of the A350, the A320, and even of the A400M, that there were massive amount of data concerning events, non-conformities arising throughout the manufacturing phases of an aircraft, which need action at some point in time, at an appropriate point in time, not to perturb the industrial flow too much, right? So at that point, that was when we started thinking that we could use artificial intelligence to help us find patterns. So first, why are certain events arising? By relaxing tolerances, tension of bolts within certain limits you can avoid. That's how we learn. We can avoid defects from arising and optimize at the end the time the aircraft does spend on the manufacturing and assembly sites. And from there, the step into thinking, wait a minute, why can't we offer this as a service also to our customers, where it was pretty short. One of the major pain points of the airlines relates to the time an aircraft needs to spend being inspected and maintained. And it's not an option, right? These are very rigorous inspections and maintenance operations agreed with the aviation authorities, so there's no deviating from those. But we started thinking, wait a minute, we can indeed gather data when our aircraft fly, and using the tools of artificial intelligence, make statements regarding the prediction of possible maintenance an airline needs to consider once the aircraft will roll into the hangar to be inspected. So we can anticipate now, thanks to almost 26,000 parameters per aircraft we do gather and analyze, we can anticipate and therefore reduce the time, the turnaround time for the airlines. So this is Skywise.
How big is Skywise? I mean, what were the gains kind of in terms of productivity or kind of?
We have now 22 airlines, 22 airlines embarked on the project, already being able to reduce by days the whole, the heavy maintenance type of check activities. So the advantages are already very, very, very visible. And of course, the more customers we have, the more relevance and pertinence our data will also have. So this is commercial aviation, right, with Skywise, which was presented at Le Bourget last year. There's another myriad of applications. We have Pléiades Earth observation satellites up there, observing the Earth 24/7. All images are stored on a cloud, and we need to draw actionable information out of these images for our customers to have value in it. And even if we sell only images, for instance, to Google Earth uses at some extent also our One Atlas offering in the sense. Our customers don't want to see clouds. Clouds not in the IT sense, but really in the meteorological sense, right? And so it was through artificial intelligence and neural networks that we trained our algorithms to recognize clouds, not to confuse them with snow fields, for instance, and filter them out. So pick the images not affected by meteorological phenomena. So what else? Telecommunication networks, secure comms, orchestrators using artificial intelligence to make sure that no matter what the traffic is, certain bandwidth is always made available for emergency operation, police operations, military communications, another type of application. And the sky is not the limit in the sense that there's some more recent developments where we are taking, indeed, artificial intelligence to space. And more specifically on the ISS with Alexander Gerst, the German astronaut currently on the ESA Horizons mission, where we have developed, on behalf of the DLR, SIMON. SIMON is an acronym for a crew artificial intelligence-based assistant. It's the size of a medicine ball, more or less, 5 kilos, with a voice, with a face, and it really does act as assistant to the astronauts, not just by taking them routinely through checklists and procedures, but in a dialogue mode, so that we can explore the man-machine interface under the demanding conditions of on the ISS, with, of course, in perspective, taking it on a more long-term type of view, the effects, crew interaction, man-machine interaction on long-term missions to the moon, and of course, why not to Mars?
Can you put a number of how important artificial intelligence is for Airbus, and in terms of kind of employees or R&D spending, so we have an idea, kind of.
It is a very transverse. There is not a team doing artificial intelligence. We have, of course, our data scientists. We have our experts, but it is so transverse that it is impossible to coordinate and isolate the spending on AI.
A number of data scientists?
We have a pool of 30, more or less.
30, okay. Now, Chris, companies kind of around the world, not just in Germany or Europe, are kind of slow adopting AI. And that's kind of the general narrative. It's not that easy. I mean, it's never easy with new IT stuff. But where do you see kind of the main barriers to implementing or making use of AI?
Actually, adopting AI is fairly easy if you look at it. If you don't make it a mathematical problem, but if you make it a process solution, an automation solution, it is actually fairly easy. Because you make it use the same systems as the people use today. So you don't have to it's not like buying a new machine where you have to rip out stuff and put in new stuff and things like this. You just add it. The really hard part for us is to accept the machine on eye level. Like a machine will make decisions and we don't control them. Like the machine will tell us to do something and we will just do it. We tell the machine to do something, it'll just go do it. This is the hardest thing for us. We always expect like industrial working from a machine, like perfectionism in churning out cars and so on and so forth, and deterministic answers. But how can you have deterministic solutions to problems if the world 1 second from now is different than the world a second ago, right? So there is no determinism in this whole field. It's very hard for us psychologically as people to accept this. And the more people you have to make a decision, the bigger the company, the more people make the decision, right, the harder this acceptance becomes.
Yeah, though, I mean, is AI really that easy? Let's start with data. Of course, companies always say we have great data and we can do something. And my guess is when you then dig into data, you realize that actually the data quality is not very high. It wasn't collected for that purpose.
The data quality is shit, right? Let's just get this right. Is we assume that data, 50% of the data collected is plain wrong, is plain incorrect. Like you have to deal with high levels of incorrectness. But the point, and this goes back to your initial question, like is machine learning AI? Right? If you're a data scientist and you just want to do machine learning, then you spend 80% of your time curating data sets. That is not what people do, right? As people, we're pretty good with little data. And that is what AI can always do if you start combining algorithms, because you can compartmentalize the problem through logic, so you have a much smaller problem to learn on, which requires less data. I think this is one of the if you're just using one algorithm, you'll have these massive problems in data. If you're using an expert system, you have the same problem with the knowledge base, right? But the three big challenges that AI really has have nothing to do with this. The first question is, how can we still make sound decisions with little data? We have answered that one, like solemnly works every day. The second big question is, how can we transfer knowledge? Like, how can we really transfer? How can you learn math in school and then use it because you're an accountant and use it when you're paying your restaurant bills? Like, how can you transfer knowledge? We can see that this will happen in our data pool already. For example, we can see that the machine making a decision where to build a city in the game of civilization is pretty much the same, like a 99.99 whatever decision process as the machine working for a real estate fund trying to decide which building to look at for investment and which ones not to look at for investment. But the data is not interconnected yet. So if there's more data and more interconnectedness, then this question of knowledge transfer will also resolve. And Moravec's paradox, which is the last big challenge for AI, meaning that everything that is easy for a person is hard for a machine, like walking, talking, and so on, and everything that is hard for a person is easy for a machine, like complicated math and so on. That is more of a question of user experience. Like, how can we have an AI have a good user experience? And just to take that one ahead, I don't believe we get it by having big-eyed, like, robots that start smiling. So that's not the point. We're not a human simulation kind of. This is not a human simulation industry. That's the wrongest path we can go down. AIs have nothing to do with humans.
Thank you. Grazia, same question to you. I mean, what for Airbus, what are the kind of the barriers you face? Kind of you have to overcome the hurdles in implementing or using more of AI.
Well, the hurdles we find within the company, of course, due to the change the AI entails, right, in the way we are doing things. So the barriers very often we do create ourselves. So there were, I spoke about what now is Skywise, right? And so demonstrating very soundly the value of what we've put in place. But it was not easy at the beginning, also because when we recognized we needed help in order to set up, to start implementing the benefits, caching and the benefits of artificial intelligence from our massive amount of data internally to begin with, we had to look for help. And there was no one on the European market at that time, 10 years ago, able to help us.
Yeah.
And so that's how we ended up with Palantir, now partnering with us, also on the Skywise program. And that did also create a lot of reluctance and skepticism within the company, due, of course, to Palantir, the nationality, the origin, the fact that the data are all on a server somewhere in the United States, which is not something, it's a pretty common practice in Europe. I mean, only 4% of European data is stored on European servers. So we're not doing anything deviating from, unfortunately, the standard. But had we had a European solution at that point, we would have dismissed all the criticism and reluctance we have found within our own company. And I can imagine that this could be a pattern other companies, a situation other companies are facing. The same with cloud. We need the potential, the full potential of cloud in order to be able to couple it with artificial intelligence and to have the dynamic advantages that such a system offers. And when we were, and with also the private variant for our defense market, of course. And yes, it's either Amazon or Google or Microsoft. So.
I mean, the question of the kind of the first part of the panel is, has Europe lost it in AI? And I want to put that to you as well. And the question is, if it does, I mean, the answer, of course, is not yet. But if it does, what does that mean, in particular, for Airbus?
Yes.
I mean, you mentioned Palantir. That's kind of one symptom.
I don't think we've lost it. I don't think the situation is that bad. What we certainly have lost is the sovereignty in terms of data. The data analysis And mostly what is relevant for Airbus today is the data flow is a battle which is not lost yet. When I talk about data flow, is that we know that data in the future will more and more go through satellite communication. So space data highways, where we are heavily investing also in optical laser terminals in order to be able to manage the flow. If you manage the flow, you have control on the data. I like to make a parallel with oil. If data is the new oil, well, we do not have it. We have no refinery, no rigs in Europe, and we need to take care that at least on the refinery and on the pipeline aspect, we do have a word in the game.
Okay, thanks, Grazia. Let me open it up to the audience since I kind of cut you off last time. Any questions to our panelists? Don't be shy.
No questions. Everybody knows everything about AI. This is
I mean, okay, if there are no questions, I'm going to continue asking. We have time, I think, for one more round. And it's that question. So there's lots of debate in Brussels and in Berlin, for example, on national AI strategies. So, Chris, what do you expect the outcome to be? I mean, as an AI company, what do you want Berlin, what do you want Brussels to do?
See, the big problem is that most of the things that politics can do are very long term. And a lot of politicians have to, unfortunately, think much more short term. And that poses a big challenge to the entire system. I think the biggest thing, so let me share first, I believe that AI is a bigger thing than the steam machine was. It's going to take us from the industrial age to a skill-based or knowledge-based age, and we can stop doing these industrial jobs that no one really loves. The real question is, can we own it, like somewhere? And the one thing that politicians can do much better than any of us techies is do the PR for it. And it doesn't cost billions of dollars. Like, currently we have this thinking of risk avoidance everywhere, meaning people have a very hard time trying it. Like, why don't we have self-driving cars yet is because we cannot guarantee that there is 0 accidents. But guys, we have drunken people on the road all the time. There is not 0 accidents. Like, can we just get it going? And that, I think, is something that we should be doing, is have a much more can-do discussion rather than trying to avoid having to explain what went wrong if something went wrong. It's going to go wrong. Like, we're going to have people killed by self-driving cars. But already, if we deployed today's technology, it would be much fewer people than we have killed by us as people.
Thanks, Grazia. Same question to you.
Fully aligned with Chris's conclusions, apply it to autonomous flying, which is also something we're looking into. It is one of our strategic technology objective, going to single pilot operations, and maybe one day.
So when's that coming? I mean, when will I be able to board a plane without a pilot?
Nowhere soon.
Okay.
I would step on that plane immediately. Like.
Great. Thank you very much. We're out of time. Yeah, thank you for the time.
Thank you.